When I started my welding project in 2003, I was given a used MFDC controller. To program this controller requires a device called the teach pendant. To change the current or time, I have to follow several meaningless steps to change the PROM memory and the controller. And I have to their school to learn how to do that. After I heard that, I gave up and told them I prefer to design my own controller. I will give them a 12-volt signal to turn the power on or off and a 2-volt signal to set the current to 10 kA. The HP 5214 liters is a preset counter manufactured by Hewlett-Packard. The right side is a 5-decade BCD switch. The left side is a 5-digit display to display the count. The instrument can generate an output pulse when a preset number of events has been counted, which can be useful for triggering other devices or processes. The weld timer works just like this instrument. So I use some CMOS logic circuit to accomplish this. This is one digit of a BCD thumbwheel switch. It has 5 pins. The first one that stand by itself is the common pin. Then there are 1, 2, 4, 8 pins. In 0 position none of the 4 pins is connected to the common pin. In 1 position only 1 pin is connected to the common. In 9 position the 8 pin and 1 pin are connected to the common. This table is the truth table of the thumbwheel switch. One thing deserve attention is from 9 to 10 it carries on the trailing edge, not the leading edge. You can stack as many switches together to count large number. To count the pulses I have decided to use a CD4518 BCD counter. Each CD4518 have 2 counters. To count in BCD code, the first stage is triggered on leading edge and all the following stages are triggered on the trailing edge. You can see the first stage is triggered on the leading edge and the second and third stage is triggered on the trailing edge. When you push the push button there will be a pulse generated to start the weld. This pulse reset the counter to 0 and set the flip-flop to the on position. A 555 timer is connected as an 1 kHz oscillator. When the flip-flop is in the on position the AND gate input will be 1 and let the 1 kHz counted. The 121N4148 diodes are used to isolate the channels. The common leads of the BCD switches are connected together and pulled high to 12 volts through a 10K resistor. Since the 0 of the switch is open, it does not enter the comparison. When the count output matches the BCD switch setting the common goes high and turn off the weld. A Born's 10 kΩ digital potentiometer is used to adjust the current. LM317 adjustable regulator is used to supply a constant 2 mA current. The trim pot is adjusted so the regulator supply exactly 2 mA. When the digital pot is adjusted to read 100 the resistance will be 1 kΩ. 2 mA times 1 kΩ equals 2 volts. This voltage is buffered then sent to the MFDC supply to give us 10.0 kA. The schematics of this weld controller are provided for you to use. First find my video how to program your weld controller to weld expulsion free. Click on the green K. Then click on More. You will find the schematics.